say 61 or 60? Oh, wow, I was off. Page 62, triangle similarity chart. Go back to 2 weeks ago, okay, in a nutshell. Go back to when we talked about congruent triangles. Meaning if I have a triangle right here, and let's say we have the hypotenuse and a leg congruent to another triangle over here, pretend like I drew it perfectly. Because of the hypotenuse leg shortcut, we could say those are exact copies, right? They're congruent. We had several ways to prove triangles were congruent. Okay, same exact concept. The difference is now it's just similar triangles, meaning I have a triangle and then I have a bigger triangle. The corresponding angles are congruent and the sides are, starts with a P, proportional. So like if this was 2, let's say, and it was a scale factor of 3, then this would be, can someone please say the number that I'm doing? 6. Y'all, participate, join me. If this was 5, this would be 15, and I'm not going to write it, well, I'm going to write it. If this was 1, this would be 3, because of the scale factor times 3. We've been looking at similar triangles. Now what we're going to do today is, instead of having to check all of the angles, all of the sides, there are 3 shortcuts for triangle similarity. There's 3 shortcuts. Not angle, 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 but angle, angle. There's 3 shortcuts. You have side, 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 angle, side, and angle, angle. Okay? If we show that all 3 sides are proportional, not congruent, you might be thinking, well, wait a minute, how can there be an SSS under both? This was all 3 sides have to be congruent, right? This is all 3 sides have to be proportional, meaning like what I just showed you right here. 2 times 3 is 6. 5 times 3 is 15. 1 times 3 is 3. So they're all proportional. Or if we can show 2 sides proportional and 1 angle congruent, or if we can show at least 2 angles congruent. Okay? So some people find this lesson easier than triangle congruence because you only have 3 things to check off instead of 5 possibilities. Let's look at the first one. If you have a highlighter, it would be helpful to highlight the big picture, big picture, big picture. Anyone else? Ryan, highlight. Yeah, highlight. See what we got. All right. Looking at angle first. Let's see. Angle, as it sounds, you have 2 corresponding angles congruent to 2 other corresponding angles. Here are 2 possible ways for it to look. These are disjoint, meaning disconnected. I have 75 here, 75 there. I have 31, 31. So because I've just checked off 2 angles congruent to 2 angles, then these are congruent by angle, angle. Not congruent, similar. So we would say triangle ABC is similar to triangle. Now look how I labeled it. A, B, C. So it would be D, E, F. So that's an example where they are disjoint. Now let's look at an example where they're actually touching. Go back to when we were doing congruent triangles. This means there is a very good chance something is not marked that needs to be marked before you can answer the question. What's not marked? Vertical angles. We've got vertical angles right here and here. Now we can look at our picture and we can see that we have these two angles congruent to these two. So we've met the AA similarity postulate. Let's label the triangles. I want to call this WXV is similar. So if I call it WXV, then I call this one what? CXY. Might have labeled it different yesterday. But anyways, so that's the AA similarity shortcut. To me, that's the easiest one to check. Now let's go to side, side, side. Side, side, side is going to require a little bit of math, okay? You're looking to see, do we have the same scale factor between every single pair of sides? So what you have to do is check that. So you do have to check all three sides and all three sides. Let me show you a technique, though, that will set it up, and then you can check it faster. The technique would be to arrange the three fractions between all the sides. Now here's what I mean by that. Side QP corresponds with side TS. So I'm going to arrange that fraction. What if I accidentally corresponded QP with TU? Let's say I was having a bad day. If I set QP with TU, am I going to get a mistake? Am I going to run into an error? How do I know that? By looking at it.
TU is the hypotenuse.
There you go. So there's a technique in labeling side, side, side that really mitigates any chance of making a mistake. Every single one of you is capable of labeling numbers based on small, medium, large. So go to the triangle and use SML to label the small number, the medium number, the large number. And then do it on the other one. So we've got small, medium, large, small, medium, large. So now instead of trying to read side number, like labels and stuff like that, now all I have to do is compare small to small, medium, medium, large, large. And you don't set it up the wrong way. Make sure to be consistent. You know, I'm gonna compare mine from this direction to that direction. So here we go. Small over small. Watch how I do this. Medium over medium. Large over large. I've just set up, Ryan, make sure you're writing this down, please. I've just set up all of the fractions for all three sides, and now what I have to do is check that they're the same fraction. Now sometimes you can do this in your head, right? I don't know how you can breathe up here. I'm going to open the door and let the heat blow out. I just tried to turn it off, but some Einsteins put the thermostat on an exterior wall, so it obviously is confused by its back side is freezing, you know, and its front side feels good. All right, we're going to check these fractions. You're going to go to your calculator. You're going to confirm that these fractions are the exact same value. All you do is enter them in the calculator. 3 divides 6, leave it. 4 divides 8, leave it. 5 divides 10, leave it. You should get 0.5 on every single one of them. Because you got the same decimal on all three, that means they have the same scale factor, which means, yes, they checked the requirement for side, side, side proportionality. So, and I'm running out of room. Triangle, I'm going to go small, medium, large. Q, P, R is similar to T, S, U. And I'll make a note right here. We went to the calculator. I'll put equals. I'm going to put CALC because we went to the calculator. Every single one of those gave me 0.5. Now, it doesn't matter what it gives you. What matters is just that it's the same number for all three. Okay? All right. I want y'all to try number 4 right here. Try number 4. Label small, medium, large.
It's fine.
It doesn't matter as long as you're consistent. But that's what I tend to do, yes. Do what? Is it?
2 are 1.25 and 1 is 1.28.
So we've got small,
The medium is
medium, large. 32 over 24. We got small, medium, large. Okay, so if you do 30, 24, medium, and large.
135. The first one is 1.25. The second one's 1.28, and the third one's 1.25.
So right here's a problem. Is it supposed to be like that? So that's what will happen is if they are not similar. So that is an example of when it does not check out. So the answer is no, they are not similar, and we can't write a similarity statement. So while the side, side, side problems do take more work, I feel like they're also very easy because you just set it up, you just type it in, and you're just checking off all three values. Which brings us to side, angle, side. Now this is a combination of the two things that we just covered. You've got to have at least one pair of congruent angles, and it has to be in between the two sides that are proportional. Location matters, okay? So let's look at this example right here. It would help if you have your highlighter and you trace the, I was going to say trace the sides, but I think it would be smarter if you do the angle. Make an exaggerated arc on the angles that are congruent, and then the two sides that that arc is touching are the ones you need to check. Okay? Make an exaggerated arc. So the angle checks off. I don't even have to do anything. Like I have an angle K congruent to an angle N. The A is satisfied. Now what you're going to do is repeat the same thing you did right here, except you only have to do it with two fractions because you're just checking side and side. instead of labeling small, medium, large, I would label small, large. So we've got 8 and 20, so that's small, large. 6 and 15, small, large. And now let's set it up. So small to small, large to large. Eight divided by 6 should give you the exact same fraction and decimal as 20 divided by 15. So I'm going to put a check. So triangle KJL, so angle to blank, I went down the small side, right, is similar to NMP. Now let's look at an example of where they would be touching. Can you tell me what you notice about the example in number 6? There's a triangle embedded within another triangle, right? Can you tell me what they have in common? Like, if I was to draw the triangles separated, what would end up being repeated because they both have it? Can you see it? If I separated the triangles, what? Angle A would end up getting written twice because both triangles have an angle A. Can you visualize it? So is it fair to say that angle A would be congruent to angle A? Which sounds repetitive. It sounds like an unnecessary thing to say. That's like saying, hey, you are the age you are. Duh. Yeah, I get it. But in math, you have to be specific. So what we can do is mark a congruent mark right here. And I just like to make it a little thicker. So I remind myself there's actually 2 angles there because there's 2 triangles here. But I can only see it the one time. So all we have to check now is our sides. And you shouldn't have to label small and large, but you can if you want to. But I can clearly see like this 15 is similar or is comparing to the 25 and this 12 is comparing to the 21. So let's set it up and let's check them.
0.6 and then 0.57.
Ooh. Does 0.6 equal 0.57? No, and if you need any help with that question, ask yourself, would 60 cents equal 57 cents? No, always relate it to money. Money's easier to understand. So they don't check out, which means no, they're not similar. But had that checked out, then they would be similar. Okay? All right. Now what we're going to do, so you just learned what we're going to practice today and tomorrow. Okay? Now what we're going to do is practice this, the same thing you just did, on this sheet. You will notice they are broken up by sections. Okay? So this entire section is saying check for what? Shortcut. You're just checking for angle angle. This whole section is saying to check for side, side, side. And then when you go to the back, this whole section is saying check for side, angle, side. This is the worksheet you are doing for the rest of class. It is a grade. There is no excuse to not finish because we have so much time left. And if you don't finish in class, You have flex today, okay? You with me? All right. No, I'm about to.